programming, and we're going to be working word problems, but today I'm just going over how to graph some things, find the vertices, and then find a maximum value and a minimum value. Like I said, it's 3.4. It's called linear programming. Homework exercises, I have given you 4 problems on page 132. Problem number 4, 17, 20, and 29. Everybody got that? Before we start, I would like to go over some things that are important for word problems and programming. First, you should read the question carefully. You should underline the question. You should declare a variable. You should write a system of inequalities. You should graph your inequalities. You should find the coordinates of the vertices of what's called the feasible region. Then you should find the maximum and minimum points and solve the problem. Now today, we don't have a word problem, but we're going to start by graphing inequality. We will find the vertices of feasible regions. We will take those vertices in the function to find the maximum and minimum values of the function. All right. So, problems we're going to be given we're going to be given some information. It says name the coordinates of the vertices of the feasible region. Find the maximum and minimum values of the function f of x, y is equal to 3x plus y for this region. The feasible region is the area that we're shading. When companies look at a profit and loss statements, they look at what is called the feasible region, and they determine where they will make their most profit. They would make their profit in the feasible region, but the question is at what point would they make the most profit or the least profit. So up here I have 3 equations that we're going to graph. The first equation, x greater than 1, is a vertical line. So we're going to draw a vertical line on x is equal to 1. And the next line is a horizontal line. And there's a horizontal line on 0. Our next equation says 2x plus y is less than or equal to 6, and y is less than or equal to negative 2x plus 6. We put some numbers in. We get 0, we get 6. We put 1, we get 4. We put 2, we get 2. And that's 0, and 2, 4, 6. 1 is 4. So basically, formed a triangle because we're shading to the right of the blue line. We're shading above the red line, and we're shading below the green line. So what we have here is this triangle inside here is what is considered the feasible region. So the shaded area is the feasible region. Everybody okay with that? I don't know whether it was in this class, but I noticed on some of the tests that I have looked at, some people aren't finding the vertices correctly. The vertices are where the lines intersect to form a polygon. So we have this point right here. We have this point right here. We have that point right there, which would be the vertices of this triangle that we formed. So what is this point right here? It is 1 and 4, right? And this point here would be 1 and 0. And then we have 4 and 0. Everybody okay with that? Correct me if I'm wrong. Let's see. Yeah. 1, 2, 3. You're right. 3 and 0. Good. Thank you. What is 3 and 0? This point right here is 3 and 0. Can you see that point, Jack? Yeah. All right. So then we're going to put together a chart. I'll give you a minute to draw the chart. All right. So what we're going to do is we're going to take the points that we found for our vertices, and we're going to put them here for x and y. So the first point we have listed is 1 and 0. The second point is 3 and 0. And the last point is 1 and 4. It does not matter which order you put them in. Then we're going to take our function, which is here, and this function right here, and plug it in. So we have 3x plus y. That function and plug it in here. We're then going to take our x and y coordinates, our points that we got, and we're going to plug in our function. So we're going to say 3 times 1 plus 0 is 3. And we're going to take our next point and plug it in. We're going to say 3 times 3 plus 0 is 9. Then we're going to take our last point and say 3 times 1 plus 4 is 7. Like I said, if you were doing this for a company, the feasible region, you would make your profit anywhere in that feasible region. But the question is, what would the maximum value be, and what would the minimum value be, and where would that value, what point would that value be at? So we need to look over here in this column and determine what is the maximum value, minimum value. So, what's the maximum value? Maximum value is 9 at the point 3 and 0. What is the minimum point? Minimum value is 3 at the point 1 and 0. This is what was called a bounded region because the figure is enclosed. It doesn't have any open sides to it. Next is an unbounded region. Yes, they gave it to us. Now, when we start working with word problems, we're going to have to make it up, but they gave it to you. Good question. So the function that is given to you is the function you're going to use. All right, so we have 3 equations up here. And we'll start with our red equation. If we subtract, we get y is greater than or equal to negative x plus 3. We plug in 0, we get, plug in 1, we get 1. We plug in 2, we get negative 1. So we have 0 and 3. We have 1 and 1. We have 2 and 8. All of these lines will be solid. Our next equation is the blue line. So on the blue line, we have 3y less than or equal to x plus 9 divided by 3. We get y is less than or equal to 1/3 x plus 3. We plug in 0, we get 3. We plug in 3, we get 4. And we plug in negative 3, we get 2. So we have 0 and 3. We have 3 and 4. And we have negative 3 and 2. Our next equation is y is less than or equal to negative 2x plus 10. So if we plug in 0, we get 10. We plug in 2, we get 6. We plug in 3, we get 4. So we have 0 and 10. We have 2 and 6. We have 3 and 4. It tells us to shade above the red line, below the blue line, and below the black line. So we would shade everything here. We do need to go back to get vertices. So this is vertices, and that's the vertices. So we have 0 and 3, and we have 3 and 4. So we want to take our function f of x, y is equal to 5x plus 4y and put it in a chart. And we want to put our vertices in our chart as well. we have 0 and 3, and 3 and 4. The reason is unbounded because it's not closed at the bottom. Plug these numbers in, we get 5 times 0 plus 4 times 3, and we get 12. Plug in 5 times 3 plus 4 times 4, we get 31. It's unbounded because it's not closed to the bottom. Okay? And if it is unbounded, you need to be careful. So be careful. The reason I say be careful is because if it is unbounded, it may not have a maximum or minimum value. So because you shaded below the line, it's not going to have a minimum value. There will be no minimum value. If we had shaded above, what would we have? No maximum value. So we want to find the maximum value. Maximum value is 31 at point 34. Alright, so tonight's homework are some problems similar to these. Some of them just ask to find the vertices, 14 and 17, and some of them you're asked to find the vertices and the maximum and minimum value. That